Okay, so go ahead, Anamia.
Pardon?
Start.
Okay. Hello. Welcome to today's session. My name is Olympia Otieno, and I'll be presenting alongside Mustafa Omar on the research paper RankRAG, Unifying Context Ranking with Retrieval-Augmented Generation in LLMs. So today's session will be covering 4 main sections. The first section will be an overview. The second section will cover the method and structure of RankRAG. The third section will be the experiments and their results. And last but not least, we'll have a demo where we'll showcase a user test case. So an overview on RAG. Large language models, LLMs, typically utilize the top K contexts from a retriever in Retrieval-Augmented Generation, RAG. So what is RAG? RAG is an AI framework for retrieving facts from an external knowledge base to ground large language models, LLMs, on the most accurate and up-to-date information. So generally, instead of relying solely on knowledge derived from training data, a RAG workflow pulls relevant information and connects static LLMs with real-time data retrieval. So despite the various advantages of RAG over traditional LLMs, current pipelines face various limitations. So one of the limitations is limited capacity of the retriever. Current RAG systems usually employ sparse retrieval or moderate size embedding models as their retriever, mainly due to efficiency considerations. So the limited capacity of the embedding model and independent processing of query and documents constrain the ability to estimate textual relevance between the question and documents, thus reducing the effectiveness in new tasks or domains. Another limitation is the trade-off of picking top K contexts. So although the state-of-the-art long context LLM can take away many retrieved contexts as input for answer generation, the performance quickly saturates with increased K in practice. So in general, a smaller K often fails to capture all relevant information, compromising the recall given the limited expressibility of the retriever. And in contrast, a larger K improves recall, but at the cost of introducing irrelevant content that hampers the LLM's ability to generate accurate answers. So on to the method and structure of RankRAG. So the diagram here, we can see the structure of RankRAG. It entails 2 phases, the training phase and we have inference. So the training phase contains 2 stages. The first stage is supervised fine-tuning, and the second stage is RankRAG instruction tuning. So to address the limitations that have just been discussed, the authors of this paper proposed a novel instruction fine-tuning framework, RankRAG. So in previous studies, instruction-tuned LLMs have demonstrated a strong ability to extract answers from relevant context for a given question. So this can be viewed as the dual capability of determining whether a chunk of context is relevant to the question and thus useful for generating the answer. So the authors hypothesized that these capabilities could mutually enhance each other. So with RankRAG, its instruction tunes a single large language model for both context ranking and answer generation in the RAG framework. So on to the first stage, which is supervised fine-tuning. SFT significantly improves the ability of LLMs to follow instructions, thus improving zero-shot results on various downstream tasks. RankRAG leverages SFT on a blend of high-quality instruction-following datasets to establish basic instruction-following capabilities. On the next stage, we have the unified instruction tuning for ranking and generation. So stage 1's SFT provides basic instruction following capabilities, but LLM still performs suboptimally on RAG tasks. Therefore, RankRAG addresses this by instruction tuning the LLM for both context ranking and answer generation. So this stage generally involves the use of a variety of data sets and tasks. We have context-rich QA data, which is to improve the LLM's use of context for generation, retrieval-augmented QA data to enhance robustness against irrelevant contexts. We also have context ranking data to empower the LLMs with ranking capabilities, and last but not least, retrieval augmented ranking data to train the LLM to determine the relevance of multiple contents simultaneously closer to the real world RAG scenarios. Also, it is worth noting that despite the variety of data sets and tasks described, they can also be cast into a standardized QA format, X, CY, where X is the question, C is the corresponding context, and Y is the target output answer. So on to the next phase, which is the RankRAG inference. As RankRAG incorporates an additional re-ranking step, the inference pipeline for each question is modified as a retrieve, re-rank, generate pipeline, described as follows. So on my right here, we have the image showcasing the inference phase. The query is also same as the question. Corpus is like the knowledge base, and so on. So the retriever R first retrieves top and contents from the corpus. We can see here it's indicated by top and documents. The re-rank model calculates the relevance scores between the question or query and the end contents, these ones here, then re-ranks context retaining only the top K contexts. So these top K contexts are what we consider as the most relevant documents, and we can see the process is indicated here. Then we have the top K contexts along with the question concatenated and fed back into the RankRAG model to generate the final answer. So on to the experiments conducted and their results. So we can see here an image of the experiments. So this table shows the results of RankRAG and baselines of 9 datasets. Unless specified, all results are under zero-shot evaluation without additional demonstrations. So the setup was as follows. They considered 3 types of tasks in the experiments. The first one was open domain Q&A. The second one was fact verification, and we had conversational Q&A. Onto the baselines, they considered the 2 main baselines, which were baseline LLMs without RAG, where they considered LLMs trained with proprietary data. And then we had the baselines with retrieval, where they evaluated models augmented with retrieval. And then last but not least, we have the evaluation matrix. They had 3. The exact math, which was used as the main metric. We had the F1 score and also accuracy. So the results were as follows. RankRAG outperformed existing RAG methods. So with the 8B scale, RankRAG consistently outperformed ChatQA-1.5 8B, one of the most recent open-sourced model with state-of-the-art performance. It also remained competitive against models with significantly more parameters, such as Instruct Rectrom, RADIT65B, and Llama3 Instruct 70B. So RankRAG 70B further outperformed ChatQA 1.570B and other RAG baselines using Instruct GPT. So another outcome was RankRAG demonstrated larger improvement on more challenging datasets. So performance gains on RankRAG over the baselines were more pronounced for more challenging datasets. So I'll pass on to Mustafa to take you through the ablation studies.
So thanks, Colombia. So here in this slide, we are going to content about the ablation study of RankRAG. Here, the authors use the Llama3-8B as a backbone for this study, and they are presenting the data for retrieval-augmented QA and retrieval-augmented ranking data, and also WA for re-ranking. mentioned that they are not going to perform a ranking in inference stage, as discussed and explained by Olympia, that we have two stages, one for the training and one for the inference. So there is no ranking in the inference stage. So as you can see here in this study, which is done in the 9 general domain dataset, we have two tables, table 3 and table 4. In table 3, we are going to discuss about the effect of the design component, and we are going to see the context tickets removal, what will be happen for the data models that we have. So on the removal of the context ranking component from RankRAG, significantly it improves the performance across all the tasks we have. This component is important for selecting the most relevant context to answer the question, or even make it effective answering this target question. We can also see the post component we have, which is RQA or RR that we discussed, that enhance the performance of RankRAG. They support the model in accurate to identify and utilizing the most relevant context for this model. So in table 4, we can see that they try to compare the performance with different LLM. So as you see, as a comparison across models that we have, it's showing us that RankRAG is consistent outperform over ChatQA, especially using the Llama 2 models. Regardless of the model size, as you see, we have different model sizes here. We have 7 and 13 and even 70, but still we can see that RankRAG is achieving performance, while the different size, it doesn't matter for RankRAG. So we can highlight that it's more effectiveness across the various model types and even the scales. From these tables, and especially in this study, we can see the contribution is specialized in training tasks. They designed a specialized task for training that focus on context ranking and identification. This task is formed as a regular question answering with instruction to enhance the model ability to select and rank relevant context. And also its integration of ranking data, which is successfully incorporated with a small fraction of ranking data into the instruction tuning of LLM, which is achieving the result compared to the model's fine tuning with significantly large amount of data that we have for the ranking data. Can you go next? Yes. So as you see the result for this study from post tables, we have for table 1 the effective of design components, and for table 4 the performance for different models. However, we are going to see by removing context ranking reduce the performance across all tasks, which is highlighting its importance in selecting relative context. However, the Retrieval-Augmented QA and Retrieval-Augmented Ranking component also enhance performance by helping the model to identify the relevant context more accurately, which is mean the other models or the other RAF method, which will retrieve context separately during the introducing or instruction for this fine-tuning result. So you can see the importance for RankRAG whenever we try to see as a performance and even as a data scale. Can you go next? So here in this slide, we are going to show the performance with different retrievals. So as you can see that there is kind of comparison between this one, and we are going to see the benchmark comparison. So compared RankRAG with several strong baseline, including the open source ChatQA-1.5, we can see, especially with using Llama 3, we are going to see that RankRAG is going to do an effectiveness way in post-general domain and biomedical RAG benchmark. So you can see the result from this number is really compared to ChatQA 1.5 is having a good result, good numbers, even good performance, which will be benefit for the biomedical range as a repository to the choice for these retrievals. Can you go next? So the result as an experience in this domain, a specific RAG benchmark, we can see the RankRAG can adaptable with also validated through experience on domain-specific RAG benchmark, particularly within the biomedical field. So we don't have any issue with this field, which is going to provide us a lot of performance and a lot of enhancement compared to other fields. And also we can see that at medical QA task, it's outperforming leading open source LLM like Mediterranean 70p, despite not being specifically fine-tuned on biomedical data. This is going to demonstrate the RankRAG approach applicability to be effective across various domains. Next slide. So here we having also ranking module, and we are going to see in this table ranking performance with different ranking models. We are going to see the baseline are used to rank is the top 100 retrieval passages. RankRAG achieved better performance despite fewer ranking data, and we can see that RankRAG with different ranking model as RankRAG is going to achieve better performance. RankRAG demonstrates significant data efficiency and strong performance compared to other RAG methods that use separate ranking model. This success is attributed to RankRAG adaptable training that closely resemble general RAG fine-tuning data. Furthermore, RankRAG achieves compiling result with just 5,000 data points with additional gains. Seen up, we have other models that they have 50,000 data points, which is confirming its data efficiency. Regarding time efficiency as well, we can see the increasing of the number of context for ranking from 20 to 100 improves accuracy, which also, if we do some calculation for the numbers that they provided here in this study, we can see there is also enhanced in the time efficiency as well. Go next. So as a result for this table as well, we can see that RankRAG in all studies and all studies that they make it in this research paper is data efficient. Achieve better recall over dedicated ranking models trained 10 times, which is really good number as a 10 times more than the other models or other models in RankRAG, which is going to maintain various tasks. Advantage is also to make sure that we have natural model training. We also can be close to reassemble of general RAG fine-tuning data. The second point, which is really interesting for most of the people, which is performance versus time efficiency for RankRAG. We can see from the result for this study that we have a good result, which is increasing the time efficiency. Even with a small ranking window from N20, it's increased to 100. And we can see that it's outperforming the time efficiency as well from the accuracy, from 5.9 to 9.1, which is going to enhance all the time efficiency versus the performance that we have. Next. So next section, we are going to show you demo as a showcase for this paper. So we are going here in this slide in table 7, which is a case study on the top retrieval context and prediction on NQ dataset, which is evaluating the effectiveness of RankRAG 8P over ChatQA 1.5 8P. So here, as you see in the table, we have red content and green content. The red one is going to show us the text dominated by descriptors, while green stands for the evidence. As you see in this table, the first section done by ChatQA and the second one provided by RankRAG. So you can see here we observe using retriever only yield noisy context, and there are several distractors and also some context in the ChatQA 1.5, which is unhelpful. However, the utilization of re-ranking uncovers two additional relevant passages, adding the model in order to provide the correct answer, which showing us the difference in one answering question between the ChatQA 1.5 and using RankRAG. And you can compare the prediction accuracy both based on the ChatQA and RankRAG and how much efficient and effective RankRAG over ChatQA. Next. So the conclusion for this research paper, the author tried to introduce a new RAG framework, which is RankRAG, which instruction tunes a single LLM for post-ranking and answering generation. And we also find in this slide and research papers that we read and we try to study that the author tried to use RankRAG in order to provide better performance and time efficiency versus the performance and how we can deal with the data with a small fraction of ranking data into the training plan. As you can see, this framework is providing much efficient work, even good time manner to handle the data compared to other model, which in different size, in different scales, we don't have issue to use the RankRAG. So thanks a lot to attend this presentation, and hopefully if you have any question or anything, also you can find the link for the paper here in the slides, the last slide, we have the link directly in case that you need to get more details about the paper and the studies that they have and the demos that they did, you can go ahead and use the link and you'll find more details about this framework. Thanks a lot.